Hey everybody. Today we're going to do our last notes for the last section in chapter 4, and it's on the trapezoidal rule. All right, and what we're going to do is exactly what we were doing before the beginning of the chapter, where we were approximating the area under the curve, and we did it with rectangles. But instead of doing it with rectangles, we're going to do it with trapezoids. All right. So everything, a lot of stuff is very, very similar. So obviously, instead of having a bunch of rectangles, we now have a bunch of trapezoids. All right. And we're going to find the area of each of these, and we're going to add them together. All right. So we're still, n is still going to be instead of number of rectangles, it's now the number of trapezoids. Delta x is still going to be b minus a over n. All right. But if we were to look, all right, so let's look at this first trapezoid. We have this. All right, so we have that and here. Okay, there's our first trapezoid. In that trapezoid, all right, our delta x is this. Well, delta x is now that, if you flip it over, that is the height of the trapezoid. All right, that's the height. So if you remember, the area of a trapezoid is 1/2 height base 1 plus base 2. So our height is always going to be what our delta x is going to be. Okay, now our two bases, they are going to be the heights or the y value. So this is just like we did before. We used to do the delta x on the outside, and we're still going to do delta x on the outside, but instead there's going to be a 1/2 out there with it. And we have two things to add up for each trapezoid instead of just one. But they come from the same places we got our things for the rectangles. Okay, now the difference is this. All right, if you look, with a trapezoid, there's two bases. So I have, in this trapezoid, I have this one right here, and I have this one. Okay, there's no left sum, right sum. You include both of them. All right, so it's this plus that. Now, notice if I had to do this again for the second one, it's this base and this base were added together. And then for the next one, it's this and that, and so on and so forth. So what you should notice is this. Every base is going to get added together twice, except for which ones? What are the two bases that aren't going to get added twice? Well, the two bases that don't get added twice are the first one, because it's only in one trapezoid, and the last one. So everything's going to be added together. It just so happens that this one here is added twice because it's in this trapezoid and this trapezoid. For instance, this one right here is in this trapezoid and this trapezoid. All right, every single one of these, except for the first and the last, are into two trapezoids. Okay, so when we are doing this, all right, it's always going to be 1/2 delta x, as you can see here, and then it's going to be the first y value plus 2 times all the middle y values plus the last y value. Okay, so we're not just going to have, we're going to have 2 times like this height, that height, that height, that height, this height, this height, this height, and then this height and that height would only be once. Okay, so the difference is that we're going to have a 1/2 on the outside with the delta x, and a lot of these heights, these bases are going to be multiplied by 2. Okay, but also similar is we're going to have from a table, we're going to have from a graph, and from an equation. All right, all of those are going to be the same. All right, so I think you'll get a good idea how to do this once we do a few of these examples. Okay, so in this example, all right, we're going from 0 to 18. All right, and here's our trapezoids we're going to have. So our delta x in this case is 3. All right, our delta x is 3. If it doesn't say how many rectangles went to the chart like this, you just assume that it's however they're spaced out. So for my area, it's going to be 1/2, because that's area of a trapezoid, 1/2. Now we put our delta x. What's our delta x? 3. All right, now we are going to do, so in this, if this was our trapezoid, our first trapezoid, here's our first, right? What our base? 10 plus 8. So it's 10, but this 8 is going to be included in this one. If I did the second one, it's also 8 plus 13, so it gets twice. So what we were saying before about 2 times all the middle ones, and one, you only have to do the ends once. From here to here is going to be multiplied by 2. So it's 10 plus, I'm just going to do 2 times parentheses, 8 plus 13 plus 14 plus 6 plus 22. That ends it, and now ends 17, because that only gets added in once. Now, you could have done 2 times 8 plus 2 times 13 plus 2 times 14 plus 2 times 6 plus 2 times 22. I just did this. It's less to enter in the calculator. All right. Now, so let's punch that in the calculator and see what we get. And you get an answer of 229.5. Okay. So just to go over this again, the 3 here is your delta x. The 1/2 is always there. You do the first and the last. I'll put this in a different color here. The 10 and the 17, they are the first base and the last base. They only get added once. All of these middle ones, 8, 13, 14, 6, and 22, right here, they all get added together twice. All right, same ideas as rectangles, but now we're just dealing with trapezoids. All right. Now, another one we did was from a graph. It's going to be the same setup, except now we look at the y values to get our things that go inside the parentheses. All right. Now, we're not given delta x here. It says n is equal to 5. So to get delta x is b minus a over n. B is 8, right? Minus a, which is negative 2, over n, which is 5. Double negative goes a positive, so we get 10 over 5, or 2. All right? Oops, 2. So it's going to be 1/2, because it always starts off with 1/2. Your delta x, which is 2. All right? Now, delta x is 2. So that means I'm going from here to there to there. So every point, basically, I'm using here. All right. So I'm going to use every single one of these y values. All right? But this one, the first y value and the last y value, I'm only going to use once. All of these y values, I'm going to use twice. All right? So first y value is 0 plus 2 times, all right, now let's put all, so that first one's negative 10 plus 10 plus 30 plus 20. So that ends the parentheses, because all those are only ones I count twice. Now this last one, 40, I only count once, because it's only in, so like if I were to make a trapezoid from there to here, right? 8, this one right here is only in this last trapezoid, where this one here is in this last one here, and also in this guy here. And that's true for every trapezoid, every height except for the first and the last. All right, so if we got that. All right, so let's put that in the calculator and see what we get. All right, and you should get, I believe, 140. All right, last one is from an equation. All right, is from an equation. All right, now you do not need to graph. All right, we do not need to graph. If you remember, we just need what's going to happen on the x-axis. And we're going from 0 to 5. We need to know how we're going to space them out. So I need my delta x, n is equal to 4. All right, so b, which is 5, minus a, which is 0, over n, which is 4. That gives my delta x. So my delta x is 5/4. So I'm starting at 0. The next, that's at 5 over 4. 5/4 plus 5/4 is 10/4. Don't worry about reducing it. 10/4 plus 5/4 is 15 over 4. And 15 over 4 plus 5/4 is 20 over 4. And guess what 20 over 4 is? That is 5. So there is our trapezoids. All right. So we have trapezoid 1, 2, 3, 4. And that's what we want. We want 4 trapezoids. Okay. Now, Same thing's going on. This first base right here, that's a bad color. This base here and this base here are only going to be counted once. These three in the middle are going to be counted twice. All right. So it's going to be 1/2. Why 1/2? Because the formula of area of a trapezoid is 1/2 height, base 1 plus base 2. So 1/2 is always there. Then the height is my delta x, which is 5/4. All right. Now we got our brackets. All right. When we get from an equation, how do I get these heights? In a graph, it was easy. I just look at the y values. Well, to get the y value, you got to plug this into here. So it's the square root of 0, which is just 0, plus 2 times, now we're going to plug in 5/4. It's the square root of 5/4 plus the square root of 10/4 plus the square root of 15/4. And I end the parentheses there because only these three, 5/4, 10/4, and 15/4 are getting counted twice. And then add whatever the square root of 5 is. All right. And now let's go put that in a calculator and see what we get. All right. So I end up getting 7.19212. All right. For your answer. Now, last thing I want to show you is that we can actually use our calculator and get the exact area of this. All right, so let me go and show you how to do that right now. All right, so now we're going to use our calculator to get the exact area. Okay, now this is how we do it. All right, what we're going to do is you're going to hit menu, 4 for calculus, and 2 for numerical integral. Okay. So we're going to hit menu 42 is what happens. All right, menu 42. All right. Now, scroll over so you can see this. All right, so now we're going to fill in this into here. So it goes from 0 to 5. And we're going to put the square root of x dx. Now, hopefully, it's roughly 7 point something. And there we go. It's 7.45356. All right. So the actual area, all right, change color, 7.4536. So not a bad approximation. It is a much better approximation than we used to get from rectangles. Okay. And if I wanted to do the percent error that actually is, all right, you can subtract these two and divide by the original. All right. Some of you guys probably done that maybe in like physics before, getting percent error. Okay. So that would be, I would do, I don't have to actually put the calculator, but it would be 7.4536 minus 7.192. And then divide that by 7.536. Doesn't matter which way for us, it doesn't matter because we're not doing what direction, we're not doing that. We'll just do the absolute value of this. So it doesn't matter which way you subtract this. And then divide, and then multiply by 100. And that would give you your percent error. Okay. So that is trapezoids, the trapezoidal rule. Like I said, very similar to what we were doing before. Now we're just doing trapezoids instead. Okay, now this is the last section of chapter 4. We have spring break coming up, so I hope you guys enjoy the time away from school. And what will end up happening when we get back with classes on the 20th of April, we will do some practice with this. I'm not going to get any practice over break with this. We'll practice this when we get back, and then we'll start reviewing all of chapter 4. We're actually going to do an assessment on all of chapter 4 before we move on to chapter 5. All right. So hope everyone has a restful break, and everyone stay healthy. And I'll be talking to you soon.